Mr. Higgins from Louisiana. 5 minutes.
Thank you, Mr. Chairman.
Sir.
Mr. Mountain, Dr. Mountain, my questions will be directed to you. I'd like to jump right into the next generation of space telescope and space technology as you envision it from your unique perspective, sir. Over the last several years, microbial life, microorganisms have been discovered to be quite resilient living in space on the exterior of the hull of the International Space Station and in experiments within minerals and rocks. Do you envision the next generation of search for life throughout the cosmos with our next generation telescopes? Do you envision them to be able to measure that spectrum by the wavelengths that we study and search for microbiotic life, as given the fact that the Hubble's been up there for quite some time, and our future telescopes have been under development for quite some time, and yet it's only recently that we've discovered microorganisms on the hull of the International Space Station itself?
And again, I can refer to my colleague, Dr. Zurbuchen. I mean, it's a very good question. So the issue is that all those microorganisms, whether they're in the space station or in the depths of the Chernobyl reactor or on these deep sea vents, they've all come from one place. It's Earth, this N=1 problem. And we know that this type of bacteria affected the atmosphere of our Earth roughly 1 billion years ago and created the oxygen that we now breathe. And so that was the signature that if we had been on another planet and looked back, we would have seen. The problem is Earths, as I've tried to say, are very faint. We haven't had the power and the capability to look at another Earth-like planet. And I think that the power of this whole idea, for NASA's perspective, is it isn't just looking around other stars. NASA wants to go to Europa. It wants to put people on Mars. All of those are potential places where life could have independently come, not just come from our Earth.
Specifically, speaking of next-generation telescopes, which is trying to stay within the parameters of the purpose of this particular committee discussion, and the search for life by investing massive sums of the people's treasure, we're discussing microorganisms and the search for them. What about silicon-based life, which has been a great deal of scientific discussion about that recently? And do you envision in next-generation telescopes the ability to detect silicon-based life?
Again, it's as Dr. Zurbuchen said, we don't yet know what silicon life would look like. And which is why we believe that the only way to look at this is to analyze the whole spectrum of another Earth-like planet, to see things we don't expect, and then try and build up models. What we understand about life is that carbon and water and oxygen are pretty essential. We don't yet know what silicon life would look like. I don't know if, Thomas, you had any further, but we haven't yet found a way to recognize what silicon life would be like.
Thank you for that answer. In the interest of time, I'd like to jump into what your thoughts are regarding dark matter or dark energy as they relate to current and next generation telescopes. Dr. Mountain, again, the telescopes we're discussing investing massive amounts of money in will be embedded within the dark energy or dark matter that we call it that because we don't know what it is. Do you envision this next generation of investment to be able to measure that in some way and to give us some answers as a people, be we Democrats, Republicans, or anything in between? We would sure like to know what dark energy and dark matter is.
As would we scientists. I mean, we are in that fortunate or incredible time where we're using telescopes like the Hubble and other telescopes. We've discovered we haven't understood where the matter comes from. That's dark matter. We haven't understood where the dark energy comes from. That's 75%. And that mystery is what's driven space missions like WFIRST. We're hoping to be able to measure across the whole sky these very weak effects and give us real insight in what physics are we missing? How is it that we sit in 2017 and we have to say to you, we don't understand what 95% of the universe is?
Exactly. And, Mr. Chairman, my time has expired, but should any of the other panel members have input, please, we would like for you to submit your answers in writing regarding the considerations of dark energy. I yield back.
That's very